Okay, let's consider our first example here. Okay, let's consider our first example here. So here we're testing a claim that 25% or more college students owe more than $30,000 in student loan debt. Okay? So just to make the language of this, let's just say 25% or more students have lots of debt. Okay? What we want to do here is figure out, suppose as researchers, we want to test this claim. So we're going to go out, we're going to collect a random sample from the population, and we're going to use that sample to come to a conclusion as to whether or not this claim is true or false. Now, we could make two possible mistakes here depending on the outcome of our hypothesis test. If we reject H0 based on our data, we could be making a type 1 error, where we're falsely rejecting a true null hypothesis, meaning the claim is actually true, but our data told us that we should reject it. So this is called a type 1 error, and we're going to describe what kind of mistake that would be. We could also, depending on the outcome of our hypothesis test, make a type 2 error. This is if our test tells us that we failed to reject the null hypothesis, when it in fact is false. So let's take a look at this. We'll write out our hypotheses. That's always our first step. Write out our null and alternative hypotheses, and then we'll describe what a type 1 and a type 2 error end up being. So keep in mind, we're testing a claim that 25% or more of college students have a certain characteristic, and that characteristic is having lots of debt. So we're fundamentally testing a claim about a population percentage. So in this case, our population percentage claim is that P is going to be greater than or equal to 0.25, which means our alternative hypothesis is going to be P strictly less than 0.25. So let's think about our type 1 error. Now, the shorthand for this is we incorrectly reject H0 based on sample data. All right, so this is what making a type 1 error involves. The way we might want to write this out is based on a sample percentage All right, so based on the results of our hypothesis test, we conclude that we're rejecting H0 based on our sample percentage. So we conclude that less than 25% have significant debt. And here's the key. When in reality, it's 25% or more. Or in other words, in reality, our null hypothesis was actually true. So keep in mind, we're identifying an error here. We're admitting that we could make a mistake. So the danger, one danger I should say, of this particular hypothesis test would be coming to the conclusion that less than 25% have significant loan debt, when in fact it's 25% or more. This is our type 1 error. This is our first type of mistake. What about our type 2 error? Just going to shrink this down and put this elsewhere. There's our type 1 error. What about our type 2 error? What would this look like? Remember, our shorthand for this is failing to reject our null hypothesis when in reality H0 is false. Two is's. Right? But what this would actually look like or mean for our particular setup here is it would mean that our sample percentage failed to provide enough evidence that less than 25% have significant debt. But keep in mind, we're making a mistake. So what's true in reality? When in reality, it is the case that less than 25% have significant debt. So in other words, we're failing to reject our null hypothesis, right? So we're failing to provide enough evidence in favor of the alternative hypothesis, when in fact it's the alternative hypothesis that's true, right? So this is one way of phrasing out our type 2 error. I had mentioned that part of doing responsible data analysis or working with hypothesis tests, etc., is sort of knowing the possible mistakes you could be making. So I want to go over one more example for two reasons. First of all, I want to give you the practice of writing out a type 1 and type 2 error. I want to give you an opportunity to self-test. But second of all, I want to cast the type 1 and the type 2 errors in a light that kind of shows you why you might want to take one more seriously than another, and why understanding these errors is important to the actual research design of your setup. So let's consider our next case here. Example 2. Suppose we're testing a claim that the use of a new seasonal allergy relief pill causes life-threatening heart failure in 5% or fewer adults. What I want you to do is pause the video and write out your null and alternative hypotheses. Okay. So hopefully you've had plenty of practice doing this. Your null hypothesis in this case is that P, which represents the percentage of people who have life-threatening heart failure when on this drug, is less than or equal to 0.05. Okay, so we're testing here again. P is the percentage of adults with heart failure as a side effect. All right, our null hypothesis is that P is under 5%. So in other words, it'd be pretty rare for somebody to have heart failure when using this allergy relief pill. And the alternative hypothesis is that it's actually greater than 5%. Now what I want you to do next is pause the video and then write out what the two possible mistakes would be. For example, what is a type 1 error for this particular hypothesis test, and what is the type 2 error for this particular hypothesis test. And after you finish writing this out, I want you to come to a decision. Which one is more important to avoid? Okay, so hopefully you gave a good faith effort here, tried to write out your type 1 and type 2 errors. Remember, self-testing is really key to understanding this. It doesn't matter if you get it wrong. The point is actually trying it and then seeing whether you got it right or not and making those corrections and making a commitment to practicing it again later. So let's go over this. Our type 1 error in this case, the big danger of the type 1 error is as follows. So in this case, remember the type 1 error would have us reject our null hypothesis. So our sample data would tell us that more than 5% have heart failure as a side effect, when in reality it's under 5%. The type 2 error is on the other side, right? In this case, our sample tells us that we failed to reject H0, so we have to presume that it's correct. So our sample tells us less than 5% have heart failure. But remember, this is a mistake. In reality, it's more than 5%. And here's why it's important to know what these errors are. Clearly, the type 2 error is way more dangerous. If you're testing this new allergy relief pill and you make a type 2 error mistake, you're assuming that your pill is safe, when in reality, more than 5% of adults are going to have serious heart complications when trying to use this drug. That's not a mistake that you want to make. On the other hand, the type 1 is not so bad. The conclusion of making a type 1 error is sort of like, well, in this case, our sample data is telling us more than 5% have heart failure, which would essentially mean, as like a pharmaceutical company, I'm going to go back to the drawing board and see if there's a way to try to, mitigate this side effect. And even though I'm wrong, I'm at least not putting other people's lives at risk. So this is not so serious of an error. So in other words, if we think about our hypothesis test, we can kind of make a decision whether we want our type 1 error or type 2 error, or possibly both, if we want to take them very seriously. And the important point to bring home here is that as researchers, we actually do have some control over how likely it is we're going to make these errors. Remember our significance level, alpha? It turns out alpha, which remember we as researchers get to choose, alpha ends up being the probability of making a type 1 error. And remember I told you that there was a Greek symbol associated to our type 2 error. We called this thing beta. Beta is what we represent as the probability of making a type 2 error. And while we're not going to go into it in too much detail, we do, as researchers, we typically set our alpha value. And based on our sample size, our alpha value, and some other conditions, we can actually compute our beta value as well. And so we do have some semblance of control over these probabilities of making these mistakes. Now we're going to talk in a little more detail in a second about this, but the reason I bring this up is that by investigating this particular hypothesis test, we've realized that the type 2 error is more dangerous. And so what we would do as researchers is make sure that beta is under control. So we would do all we can in the design of our sample collection and the design of our experiment to make sure that beta is as small as possible, because this is the mistake we don't want to make. Even if making beta small sacrifices making alpha a little larger, we're going to be okay with that. And this is why it's important to really know the type 1 and the type 2 errors, because it really helps you make some sound decisions, and it helps you be safe as a data analyst. I just want to make a couple of final comments and thoughts on hypothesis testing errors. First of all, keep in mind this significance level, which remember controls the probability of making a type 1 error. We choose this before doing the experiment, right? So oftentimes we say, I want to use a significance level of 5%. And what essentially this means is I want there to be under 5% chance of making a type 1 error in this particular hypothesis test. Unfortunately, right, we talked about this natural balance between controlling the probability of a type 1 error with the probability of a type 2 error, right? We don't want to make either mistake. But unfortunately, lowering your probability of a type 1 error ends up making the probability of a type 2 error larger. So we have this natural pull and push between alpha and beta. If you're more likely to make a, or if you're less likely to make a type 1 error, you're more likely to make a type 2 error. So we often kind of have to balance our desire to make one bigger or smaller. We prioritize. And this is somewhat what we were kind of getting at with our last example. There is a way to make both of them smaller simultaneously. The only way to do this is to increase your sample size. This has a natural effect that will lower both the likelihood of your type 1 error and the likelihood of your type 2 error. So once again, more data is king, right? If you increase your sample size, you're naturally going to decrease both of these, regardless of kind of the push and pull.